Welcome to Logic Bytes. In this video, we walk through an applied example of maximum likelihood estimation using door-to-door fundraising data. A charity has recorded how many houses a volunteer must knock on between successful donations. The observed values are 10, 8, 5, 9, 17, 12, 7, 12, 10, and 21. That's a total of 111 unsuccessful visits. The charity assumes that each attempt is independent and identically distributed, and models the data using a geometric distribution. The task is to estimate the probability of success, which we'll call P using maximum likelihood. Then we'll calculate the asymptotic distribution and construct a 95% confidence interval. MON. We model the number of failures before each success, x1 through xn, as geometric with unknown parameter e sub p. The probability mass function is, the probability x equals x is 1 minus p to the power x times p. We form the likelihood by multiplying the probability mass functions. This simplifies to 1 minus p to the sum of xi times p to the n. The log likelihood becomes sum of xe times the log of 1 minus p plus n times log p. We take the derivative of the log likelihood, set it equal to 0, and solve for p. This gives the maximum likelihood estimator, TPE hat, equals n divided by n, plus the sum of xi, which is 10 over 121, approximately 0.083. We now compute the second derivative of the log likelihood to confirm this is a maximum. The result is always negative, which guarantees it is. To compute the expected information, we use the fact that the expected value of xi is 1 minus p over p. The MLE is asymptotically normally distributed with mean p and variance p squared times 1 minus p over n. Since we don't know p, we use observed information at the MLE. This gives us an approximate confidence interval of 0.03, 305 to 0.1317. We can validate our findings by plotting the log likelihood function. The plot confirms the MLE and shows the range covered by the confidence interval. A few caveats. First, the assumptions may not hold. Are visits really independent? Do all households have the same likelihood of donating? Second, we are using an approximation. The asymptotic normality and observed information are not exact. That wraps up our example of maximum likelihood estimation in practice.